Hello everyone, welcome to my channel. Today let us learn the concept of speed, distance and time. Before getting into the topic, let us get introduced to some of the important concepts. This concept determines the fundamentals of motion, representing how fast or slow the object moves, or how far it travels and how much time does it travel, like the duration of its movement. Speed is defined as the rate at which certain distance is covered. Now let us understand some key terms. Distance represented by d, the total length covered by an object. It is measured in meters, miles, kilometers, etc. Time t, the duration of the action, like the interval separating any two events, like it is measured in seconds, minutes, hours, etc. And speed s, the rate at which an object covers the distance per unit of time. It is measured in meters per second, kilometers per hour, miles per hour, etc. Before trying to solve some problems, let us understand the basic relationships and remember some of the important formulae. And remember one thing, while establishing any relationship between the two terms, the third one is assumed to be constant. Now, for example, the relationship between speed and distance. Here, time is assumed to be constant. Here, speed is directly proportional to distance. Like if an object travels for a fixed time, higher is the speed, then higher is the distance traveled. Same way, relationship between speed and time when distance is constant. Speed is inversely proportional to time. Like if an object travels for a fixed distance, if the speed is higher, then the time taken is lower. And the relationship between distance and time is distance is directly proportional to time. If an object travels at a constant speed, to cover a higher distance, the time required is also higher. And one of the important formula, average speed is equal to total distance traveled by total time taken. With the established relationships, the general formula goes like speed is equal to distance by time, distance is equal to speed into time, and time is equal to distance by speed. While calculating these problems, for easy rememberings of this formula, just draw this thing y, like here d, s and t. Distance is equal to speed into time. Speed is equal to distance by time, and time is equal to distance by speed, as it goes here. One main important thing to remember before calculating any problems is make sure that the units are consistent. Like for example, if the speed is measured in kilometers per hour, then make sure that the time is measured in hours and the distance is measured in kilometers. If it is in other units, convert into the same and then do the problem. Now let us try to solve some problems. First one, if a man increases his speed to 3 by 2 times of his original speed, then he reaches his office 20 minutes before the usual time. How much time does it usually takes to travel the office? Here, first identify what is the given data and which is the constant term. He Here there are two cases, actual speed and the speed 3 by 2 times, and the time is 20 minutes early and the usual time. So the distance from his home to office is constant. So here the distance is constant. Speed is inversely proportional to time. In the first instance, the speed and time multiplication, which is equal to distance, is equal to the second instance. Like for example, if his usual time is t1 and usual speed is s1, and if his speed is increased 3 by 2 times, that is 3 by 2 times of s1, and his time is reduced, t2 is equal to t1 minus 20 minutes. So s1 t1 is equal to s2 t2. Here while doing the calculation, we replace the s1 and t1, s2 and t2, and here the sum goes t1 into 2 by 3 is equal to t1 minus 20. 20 is equal to, by rearranging the terms, you get t1 by 3 is equal to 20, and the actual time taken is 60 minutes. Now let us try with some other example. A, B, C, three are running in a running race of 5000 meters. A runs twice as fast as B, and C runs 1 by 5th as fast as B. If C completes the race in 50 minutes, Then where are C and B from the finishing line when A finishes the race? Also determine in how much time does B and A finish the race. Here this question is an example of indirect data. Here the data is not given directly, only the distance and the speeds between relationship between the speeds of A and B and C is given. There is no direct data other than 5000 meters race, and one data they gave is C is completing the race in 50 minutes. See now, here the total race distance is constant, only the speed and time is different for each of the racer. Here the distance is constant, A, B and C. First we will write the data for C, because the time for C to complete the race is given, and also the relationship between C speed and B speed is also given. Distance is equal to 5000 meters, time is equal to 50 minutes. Then speed of C is equal to distance by time, that is S is equal to 5000 by 50 by cancellation. Speed is equal to 100 meters per minute. Now one more relationship between C and B's speed is speed of C is equal to 1 by 5th speed of B. So by this you can calculate the speed of B. Speed of B is equal to 5 times the speed of C. So the speed of B comes to 500 meters per minute. Now speed of B and speed of A, there is a relationship given that speed of A is 2 times the speed of B. Now speed of A is equal to 2 into 500 meters per minute, so speed of A is 1000 meters per minute. Now the question goes, when A finishes the race, where are C and B from the finishing line? To calculate this, calculate the time by which A finishes the race. A complete the race in D by S, that is total 5000 meters by 1000 meters per minute. So A completes the race within 5 minutes. How much time does B takes to complete the race? T is equal to distance by time, that is distance traveled is same 5000 and the speed of B is 500 meters per minute. So the time taken by B to complete the race is 10 minutes, and A completed the race in 5 minutes. After 5 minutes, distance traveled by B, because we need to calculate what is the distance from the finish line for B and C when A finished the race. A finished the race in 5 minutes. So after 5 minutes, the distance traveled by B is equal to speed of the B into time taken by B. So time taken by B is 5 minutes. So speed of B is equal to 500. So 2500 meters. How far from the finish line? He covered 2500 meters at the end of 5 minutes. So from the finish line is 5000 meters total finish line. So from that 5000 it is 2500 meters away. And calculating for C, after 5 minutes distance traveled by C is speed of the C into time is 5 minutes constant, speed of C is 100 meters per minute, so distance traveled by C is 500 meters. So from the finish line, that is 5000 minus 500, so C is at a distance of 4500 meters at the time when the A finishes the race. In any problem, just find what is the given data, what is the relationship we need to establish, and what are the constant terms, whether it is direct or indirect, and so on. If you are able to identify these kind of terms, then you can calculate the problems very easily. Coming to the third problem, Raju and Ramu travels from X to Y at 24 kilometers per hour and 26 kilometers per hour respectively. That means speed of the Raju is 24 kilometers per hour and speed of Ramu is 26 kilometers per hour. Distance between X and Y means the distance between 2 points is 98 kilometers. Both of them start from X towards the Y at the same time. Ramu reaches the point Y, since his speed is higher than Raju, reaches the point Y and immediately returns back towards X. So, and he meets the Raju at a point Z. Now find the distance of the point Z from the point Y. See, let us draw an illustration line. Both are starting from the point X and moving towards point Y, and since the speed of the Ramu is high, Ramu reaches the point X and again comes back. Meanwhile, Raju is also going towards the point Y. So let us assume they meet here at a point Z. The total distance traveled is distance between X and Y is 98 kilometers. And remember, here They both meet, they both start at the same time, and they both travel towards a single point, reaching Ramu reaches Y and again get back. So here the time taken for traveling is same, and the distance traveled by Ramu is much more because he crossed Z, reached Y, and again came back to Z. But Raju is not even crossing Z. So the time taken is same, distance traveled is more by Ramu, and the speed is also different. So here we need to establish a relationship. Speed is directly proportional to distance. So speed of the Ramu by speed of the Ramu by distance traveled by Ramu is equal to speed of Raju by distance traveled by Raju. Here the given data is speed of Ramu is 26 kilometers per hour, speed of Raju is 24 kilometers per hour, and the total distance is 98 kilometers. Distance traveled by Raju is 98 minus Z. This let us assume this distance as A. So they meet at a point Z. Total distance traveled is 98 minus A, and total distance traveled by Ramu is 98 plus A, since he reached all the point Y and again coming back at a distance A. And Raju did not reach Y, he is still at a distance far from Y. So distance traveled by Raju is 98 minus A, and distance traveled by Ramu is 98 plus A. So speed of Ramu 26 by 98 plus A is equal to 24 by 98 minus A. Cross multiplication of these two terms, 26 into 98 minus 26 into A is equal to 24 into 98 plus 24 into A. By sending the terms to left hand side and right hand side similar terms, we get A is equal to 26 minus 24 into 98 by 50. Here A is equal to 2 into 98 by 50, that is A is equal to 3.92 kilometers. That means both of them reaches meet at a point Z, which is 3.92 kilometers away from the point Y. Let us try solving another problem. Ramu travels 48 kilometers at a speed of 12 kilometers per hour using bike, travels 62 kilometers at a speed of 31 kilometers per hour using car, and 105 kilometers at 15 kilometers per hour in bus. Find his average speed for the total distance traveled. Here we remember the formula, average speed is equal to total distance by total time. Here Ramu uses 3 different modes of transport and travels at 3 different speeds, and he completed his total journey with using 3 different modes. Now the distance 1 traveled is 48 kilometers using bike. Distance 2 traveled is 62 kilometers using car and 105 kilometers using bus. So the total distance is equal to 48 plus 62 plus 105, it is 215 kilometers. Now to find the average speed we need the total time. There is no data given for total time, so we extract the total time by using the speeds. Now time is equal to distance by speed. Time travel for first thing, like using bike, is equal to distance by speed. Like distance for bike is 48 kilometers and speed using bike is 12 kilometers per hour. So d1 by s1, that is 48 by 12 is 4 hours. And the similar way, distance traveled by car is 62 kilometers and speed is 31 kilometers per hour. So the time taken is 2 hours. And time t3 is equal to d3 by s3. Distance traveled by bus is 105 kilometers at a speed of 15 kilometers per hour. So 105 by 15 comes to 7 hours. So the average speed is equal to total distance by total time. Then the total distance is 215 kilometers, and by calculating we get 215 by 13, that is 16.54 kilometers per hour. The average speed is 16.54 kilometers. By using this kind of formulae and these kind of relationships, one can solve any kind of problem related to the distance, speed and time. If you have any doubts regarding the concept, do drop your comments. Thanks for watching. Please subscribe channel for more such content.